You know, every single day, your doctor is making these huge decisions about your health based on a world of data that we almost never see. We're talking lab results, right? Blood tests, biopsies, all of it. We get the numbers, we get the diagnosis, and we just trust them. But have you ever really stopped and thought, why? Why can't we trust them? What's the invisible safety net that makes sure the number on your report is actually the right number? Well, today, we're going to pull back the curtain on the clinical lab and show you the incredible unseen system that's guarding your health. It's called the Quality Management System. Let's get into it.
So here's our game plan. First up, we're going to look at the really high stakes of what happens when results go wrong. Then we'll introduce the hero of this story, the lab's own guardian angel system. After that, we're going to get super practical and follow one single blood sample on its entire trip through the lab. Then we'll zoom out and see who actually makes and enforces these rules of quality. And finally, we'll tie it all together to see how this whole complex system turns raw data into a diagnosis you can actually count on.
All right, section 1, when results go wrong. Look, before we can really appreciate the system that keeps us safe, we have to face the dangers it's built to prevent. Because in medicine, a tiny little error isn't just a simple mistake. It can literally change someone's life forever.
Okay, so let's make this personal for a second. Imagine you go in for a checkup. They draw a vial of blood, and a week later, you get a result. How can you be 100% certain that that vial was your vial, or that the machine that read it was perfectly tuned, or that some simple human mistake didn't add or subtract a 0 from a critical number? The thing is, we take this on faith, but our trust is only possible because of a very deliberate, very carefully built system designed to answer every single one of those questions.
Now this is terrifying. And I want to be clear, this is not some made-up scary story. This is a real thing that has happened. Just think about how this goes down. It starts with a simple mistake. Someone puts the wrong label on the wrong tube. That tube then goes through a perfectly good system. The machines are working fine. The tests are run correctly. An accurate result comes out. But it's for the wrong person. And the outcome? It's a catastrophe. One patient gets blasted with toxic chemotherapy they never needed, while another patient, who desperately did need it, gets nothing. It's just a brutal reminder that the whole system is only as strong as its weakest link.
Okay, so moving into section 2, the lab's guardian angel. If the potential for error is that high, and the consequences are that serious, how do labs even operate? How do they possibly protect us from these kinds of failures? Well, the answer is a whole philosophy, a whole framework, known as the Quality Management System. Let's really define what a QMS is, because it's not just some manual sitting on a shelf. It's the entire quality ecosystem of the lab. You can think of it like the lab's constitution. It covers every single person, every piece of equipment, every procedure. And its goal is to make sure every result meets 4 critical standards. It has to be accurate, meaning it's the real value in your body. It has to be precise. If you ran the same sample 10 times, you'd get the exact same result 10 times. It has to be timely. A perfect result that's 2 days late is totally useless in an emergency. And finally, it has to be clinically useful, meaning it's presented in a way a doctor can understand and act on right away.
So you see, a strong QMS isn't just some dusty binder of rules sitting on a shelf. It's really a whole philosophy. It's built on a foundation of 7 key principles that shape every single thing the lab does.
Okay, principle number 1 is customer focus. Now, you might be thinking, customers in a lab? But yeah, in this case, the customers are the doctors and nurses who need clear, easy-to-understand results. And, of course, the patients they're treating. So the lab is always asking for feedback, like sending out surveys to doctors to ask, hey, was this report clear? Could we make it better for you? Next, you've got 2 ideas that go hand in hand, leadership and engagement. You see, a culture of quality has to come from the top. The lab directors have to live and breathe this stuff. But it also takes an engaged team on the ground. Every single person in that lab has to be trained, has to feel supported, and has to feel like they have the power to be a guardian of quality. The system also depends on a process approach and a constant hunger for improvement. What that means is the lab doesn't just look at one little task at a time. No, they look at the whole shebang. They literally map out the entire journey of a sample from start to finish, just to find weak spots or traffic jams. And then they use that data to make the whole process better, safer, and faster. And the last couple of principles really tie everything together. First, decisions have to be evidence-based. That means they're driven by science and data, not just, well, this is how we've always done it. And that goes along with relationship management. A lab can't be an island. They have to work super closely with doctors and nurses to make sure the right tests get ordered in the first place, and then everyone understands the results when they come back.
So what's actually in this QMS toolkit? Well, let's look at a couple of key things. You've got standard operating procedures, or SOPs. These are the bedrock. Think of them like a detailed recipe for every single task, making sure a test is done the exact same way on a Tuesday morning as it is on a Saturday night. Then you have things like proficiency testing, which is basically a final exam for the lab. They get sent blind samples from an outside agency, and they get graded on their accuracy. It's a whole system of constant checks and balances, creating this multi-layered defense for your sample.
So, Section 3, the journey of a sample. To really get how a QMS works, theory just isn't going to cut it. We need to see it in action. So we're going to follow a made-up blood sample, we'll call it sample alpha, from the second the doctor orders the test all the way to the final result. And we'll see all the potential traps at each stage and how the QMS is there, acting as a safety net every step of the way.
This journey is pretty much always broken down into 3 main phases. First, you've got the pre-examination phase. This is literally everything that happens before the sample gets tested, from the doctor's order to the sample showing up at the lab. Then you've got the examination phase. This is the part we all picture, with the high-tech machines doing their thing. And last, there's the post-examination phase, which is everything after a number pops out, like checking the result and getting it to the doctor. A mistake in any one of these can make the whole thing worthless. Okay, let's kick it off with phase 1, pre-examination. Now, here is probably the most shocking fact in this entire explainer. Study after study shows that up to 70%, 70, of all lab errors happen right here, before the sample even gets close to a multi-million-dollar analyzer. This is where the basics are absolutely everything. Making sure it's the right patient, drawing the blood the right way, and getting it to the lab under the right conditions.
And this just shows you how easy it is to mess up. Using the wrong tube isn't a small thing. Those different colored tops have different chemicals in them, and the wrong one can totally wreck a test result. Mislabeled tubes, we already know how bad that is. Wrong temperature can destroy whatever it is you're trying to measure. And that last one, hemolysis, is kind of wild. If you shake a blood tube too hard, the force literally breaks open the red blood cells and they spill their guts, like potassium, into the sample. That can create a fake, terrifyingly high reading that looks like a life-threatening emergency. So let's see the QMS in action. In a lab without a good system, a patient's potassium comes back sky high. The doctors start scrambling, thinking they have a cardiac emergency on their hands. But the problem isn't the patient, it was a badly drawn sample. A QMS doesn't just hope that doesn't happen, it builds a process. It sees hemolysis as a problem, so it creates a fix. A standard checklist for drawing blood is made, everyone gets retrained on how to handle the tubes gently, and then they track the data. The problem isn't just fixed once, it's systematically stamped out. Okay, on to phase 2, the examination phase. Our sample alpha has made it to the lab safe and sound, and now it meets the machines. This is the analytical core of the lab, filled with these incredible automated instruments. But these things are not magic. They're like a high-performance race car engine. They need constant tuning, constant maintenance, and constant checks to make sure the data they're spitting out is right. The errors in this phase are a bit more technical, but they're just as dangerous. Calibration drift is the sneaky problem where a machine just slowly, day by day, gets a little less accurate. Reagents, the chemicals that make the tests work, can go bad. The instrument can just have a mechanical failure. Or, even with all the automation, a human can still make a mistake. A good QMS has a plan for every single one of these possibilities. Here's a perfect example. A glucose machine is supposed to be calibrated every day, but someone forgets. It doesn't explode, it just starts to drift, reading every single sample a few points higher than it should. Over a month, that could be the difference between a doctor telling a patient their diabetes is under control versus telling them to take more insulin, which could be dangerous. The QMS solution is smart. It's got software that literally won't let the machine run unless it's been calibrated. And they run daily control samples with known values to make sure the machine is hitting the bullseye. It catches that drift before it ever affects a real patient. So finally, our sample alpha has been tested and an accurate number is ready. We're home free, right? Nope, not even close. Now we enter the post-examination phase. This is the crucial last mile. A 100% perfect result that gets reported wrong, sent to the wrong doctor, or just never gets seen is a total failure. This whole stage is about making sure the data is solid, verified, and communicated effectively. And the dangers are just as serious here.
A critical value, like a dangerously low blood sugar, needs to be reported in minutes, not hours. A simple typo, typing an 8 instead of a 3, can change everything. A new tech might see a weird result, but not know they need to show it to a senior pathologist. Even just the design of the report can be a problem. If it's confusing, a busy doctor could easily misread it. Picture this. A patient is bleeding internally after surgery. The lab correctly finds their hemoglobin is critically low. They need a blood transfusion, like now. But without a QMS, that result just sits in some computer system. That delay could be fatal. The QMS solution is an ironclad policy. Any result that hits a critical level sets off an alarm. The rule says a tech must immediately call the patient's nurse or doctor directly, have them read the result back to confirm it was heard correctly, and document the whole thing. It turns a passive piece of data into an active, life-saving alert.
All right, Section 4, the rules of quality. Now you might be thinking, okay, this is a great internal system, but who's making sure the labs actually do all this? Who holds them accountable? Well, a lab's quality system doesn't just exist in a bubble. It's built and enforced by a powerful team of federal regulators, accrediting bodies, and standards organizations.
Think of it like a 3-layered shield that protects you. At the very top, you have CLIA. That's federal law. It sets the absolute minimum quality standards that every single lab testing human samples in the U.S. must follow, no exceptions. Then you have the accreditors, like the College of American Pathologists or the Joint Commission. These guys are the inspectors. They take the law and turn it into these massive, detailed checklists and then show up on site to make sure labs are following the rules. And finally, you have organizations like CLSI. They're the ones who literally write the playbook, the super detailed expert guidelines on how to do a test or set up a quality system. Together, these three create this amazing ecosystem of accountability. And that brings us to our last and, honestly, our most important section, from data to diagnosis. We've gone on the journey with our sample, we've seen the dangers, we understand the phases, and we've met the rule makers. So let's zoom all the way back out and ask the big question. Why does any of this matter? Well, it all boils down to this. Every single checklist, every calibration, every procedure, every inspection, all of it, every single bit serves one ultimate purpose: patient safety. This entire complex, invisible system is designed from the ground up to be a safety net that protects you. It makes sure that when your doctor makes a decision, whether it's what medicine to give you or whether you need surgery, they're basing it on information that is as accurate and as reliable as it can possibly be. It's the silent, tireless guardian of your health. And that really brings up a bigger idea, doesn't it? We just unpacked the quality management system that our entire modern medical system is built on. It really makes you wonder, what other huge parts of our world depend on these same kinds of invisible systems? From the incredibly detailed protocols that air traffic controllers use to keep planes safe, to the quality control that makes sure our food doesn't make us sick. Our lives are constantly being protected by these hidden frameworks. It's just a powerful reminder that behind every simple, trusted thing in our lives, there's usually a very complex, very dedicated system making it all possible.